root minus 1 acts as an operator which rotates an object by 90 degree. So this was the physical significance of root minus 1. Unlike 1 maybe which rotates an object by 0 degree. Unlike minus 1 which rotates the object by 180 degree. Right, so this was 1 degree pi angle rotation and this was pi by 2 degree rotation, 90 degree rotation. That was the physical significance. Now what exactly we are going to do with this? So we have seen like we have something called eta here which is by definition root minus 1 and we define I square equals minus 1. So this is by definition. And again when you write I square is minus 1 I can be written as plus minus 1, but by definition we select to be root minus 1, we call as eta, right? And then we have real world, real numbers, which is basically 1 0 pi 122 by 7 minus 2 minus 3 e etc. And there is a tug of war between I and this. Now fundamentally they can't fight because eta needs them. Why they needs them? Because I is an operator, so this operator must be operated on something. So the stuff on which that they will get operated is the real chunks. So we have, let's say this is zeros, we have real numbers like 1 2 3 4 5 6 so on and many in between 2.71. so if I multiply I with 1 with I, it goes over here, 2 with I, it goes 90 degree rotation, 3 with I 90 degree. So all these guys somewhere, right? So we want in fact a combination of both of them to create a new set of numbers, and that's what is known as complex number. So we want complex number to be combination of this mix of I and reals. Now this mixture of I and reals makes sense because all reals number will be sitting here on the x-axis, and when I multiply this with iota, it will transport this to a new world. So this is new location. So this was this old location. So both combined is basically we can think of its new location and old location together. Can we think of an odd ordered pair like double balls? Okay, what I mean, so let's say if I combine both of them, and if I talk about some number called 1 plus I, what exactly it means? What's the meaning of plus over here? It's just like talking about 1 apple plus 1 orange. Because even if you treat I with a number called root minus 1, there is no much significance of this, because in fact you can't add 1 with root minus 1. They are completely on different axes. So you can think of apple axis, orange axis, and 1 plus I denotes 1 apple and 1 orange. So basically it's just an ordered pair of 1, 1. So this plus has already lost the significance. Okay, so it has lost its significance of being plus over here. So as to treat 1 plus I is just 1 plus I. So 1 plus I is nothing but either I plus 1 or 1 plus I. You can't further add actually. This addition itself is a misnomer, because 1 plus 1 equals 2 makes sense. We are adding two objects of same physical quantity and give something like some two different species you are trying to combine. So until you make a juice out of it, one apple and one orange is going to be one apple and one orange. So if we have 1 plus, let's say 2y, that's again one apple and two orange kind of a step. So on apple orange axis, you can keep this as 1 comma 2. Of course, we can also have -1 minus I, which feels like -1 apple and -1 orange. So in kind of still it starts giving you non-realistic physical meaning, but not every time we are interested in apple and orange, right? Negative numbers do make sense when you are in debt or something. So when you are loss, you make like a 10 rupees loss means you have a status of minus sense. In that sense, when negative number are natural way of describing the number system or describing the physical world. Okay, so now I know like every number which is in the form of x plus y, means every number which is in this fashion has its place, had its home or shelter in the xy coordinate system. Later we'll see like formally it's not legal to call xy coordinate system because we have apple and orange axis or some new I world. So because of this ego problem, we'll call this some other plane, which is Argand plane or complex plane. But what's important to know, like complex number is doing almost nothing. It's just behaving like a catalyst in the entire reaction, because the complex mixture of real and imaginary is fundamentally just two real numbers, right? So x is real, y is real. So what constitute x plus I? Y is two real identities. Plus has lost the significance, so it's just a separator. It's like instructor of telling you have two different species, and I is just an operator. Okay, so x alone you are in one dimension, y alone is still you are in one dimension. So x plus I y is basically, so these real numbers and y is also real. So fundamentally we have all x and y coming from 1D, right? And moment you multiply a real with I, you are transformed into a new dimension. So x plus y is fundamentally behaving like a two-dimensional ordered pair. So it's creating 2D world, which was already discussed in the previous lecture. So now when we have a visualization, the takeaway is for every x plus iy, it can be represented just as an ordered pair, where there is no meaning to plus to it, so just a separator, and I is an operator. Okay, so now we can come with the algebra of complex numbers. So first thing first, under what condition two complex numbers will be equal? So let's say if I have x plus iy, and if I call 2 plus 3i, both of them equal. So what will be the value of x and y? Is there any unique value or more possibilities? So clearly 2 plus 3i, you can think of a ordered point 2 apple and 3 orange, and that's equal to x apple and y orange. So if those both guys equal, if 2 point is same, so their GPC location must be same. So that gives x equals 2 and y equals 3. Basically this is how you define it. Again, the motivation for this definition is quite natural, because you can take even x minus 2 plus I times y minus 3 equals 0, right? Or I can write as x minus 2 equals minus I times y minus 3. Although right now I have not defined like how to multiply it, but you can see as the complex number was a natural extension of the real number system to a new dimension. So all rules of algebra, all laws of algebra will still hold. Laws of real numbers still holds, because it's an attempt to mimic the idea of real numbers and to push forward to a new dimension. And 2D is nothing but it's collection of 1D in two different directions in that sense. So hence you are allowed to square it as well. So x minus 2 whole square minus I square will give minus 1, because it's I square which is equals minus. So we are getting minus y minus 3 whole square. And now it should not be surprising for you if you put everything on one side. Clearly the sum of two real numbers is 0, and that's non-negative, so only possibility is this is 0, this 0, which gives x2 and y3. So this is another way of visualizing if two complex numbers are equal, equality and they must have equal real and equal x and equal y, right? Second point is, can we compare two complex number? So is this allowed, like one will be greater than other or less will be other? So let's see with a motivation example again. Let's say if you have 2i and I. So maybe some of you might feel like 2i is greater than I because I we can cancel and 2 greater than 1. And that doesn't make much sense because I is not positive or negative number. But still, since I've asked you to mimic the ideas of algebra, so it might make sense. So let's say logic number 1 will be, let's cancel I and take 2 greater than 1. Since this holds, so that must holds. Then your friend will come with another logic. He'll be like 2i greater than I, let's say square both sides. Because anyway, there's no negative sign, so you might be tempted to feel like I is kind of plus I, right? That will give you 2i whole square is greater than I square. Implies minus 4 is greater than minus 1. Again, that nonsensical. So 2i greater than I makes sense, and if you cancel, and does it make sense if you square it? At the same time, it also takes logic number 3. If you think like 2i minus I is greater than 0, it shows like I is greater than 0. What does it mean even? Root minus 1 greater than 0. It's again nonsensical because root minus 1 you visualize an operator. Okay, so root minus 1 cannot be treated as a positive number, negative number, or 0. The reason is these all logics are contradictory. Okay, so you don't have a definite way of telling this. So law of trichotomy. Trichotomy means if you have two real numbers, either one will be greater or smaller, or they'll be equal, right? So you have three possibilities. That's why they call it law of trichotomy. These are fanciful English words anyway. So we never compare two complex number. The more fundamental logic can be given as if we have two complex number. Let's say one is 1 plus I, other is let's say I only. So 1 plus I is represented by point 1 comma 1, and I is 0 plus 1i. So we can represent that as 0 comma 1 over here, right? So now clearly these two points, there is no meaning of comparing the points. What you can compare, maybe distance or maybe the angle that these vectors form, those line segments form. But so angles can be compared, magnitude or distance can be compared, point cannot be compared. I can't tell like this point is more superior than this. You might think like, okay, let's tell it because it's right side, then you can come with coordinate system here, okay, and this becomes left, this becomes right. So in that sense, and maybe if I can come with coordinate system here, they are on the same level. Okay, so basically that notion of who is more superior in with respect to point is completely ambiguous thing. The third point is, so what we have seen like equality and we can't compare. Third point is addition. So we mimic the same thing. If you have got, let's say, complex number 1 plus 2i and you are adding 2 plus 3i. So it's just like we have 1 apple and 2 orange and 2 apple and 3 orange. So of course we're tempted to think of 3 apple and 5 orange, 3 plus 5i. Okay, I works as an operator. So pictorially also this can be visualized. Now when you know 1 plus 2i can be visualized as 1 comma 2, just as an ordered pair, 1 apple and 2 orange, 1 apple and orange axis. 2 plus 3i you can visualize as you have 2 and 3. So somewhere 2 and 3. So where exactly 3 plus 5i will go? Okay, let's do a little bit experimentation. So if I connect 1 comma 2 with origin, so with respect to origin they have some GPS location. Let's try to draw a line which is parallel to this first line connecting 2 and 3. And let's try to draw a line which is parallel to, let's say this is OAP, parallel to OA now. So it will intersect at a point, let's say x comma y. So these two are drawn parallel, this guy is parallel to this. Now you know, since this is a parallelogram by our construction, so what about the diagonal? So how to calculate x comma y? So diagonals of parallelogram, they bisect each other. Since they are bisectors, midpoint of AB will be same at midpoint of when that point P, right? So what is midpoint of AB? 1 plus 2y2, comma 2 plus 3y2. And midpoint of OP is x by 2, comma y by 2. And you can clearly see from here you are getting x equals 3 and y equals 5. So just their coordinates gets added. And that's surprising because that's exactly the answer which is matching over here. So directly have proved law of vector addition, like why this summation is equivalent to as if you draw a parallelogram, because from fundamental parallelogram midpoint. So if you know point A and B, you can easily calculate B from midpoint theorem. That gives you exactly this is the location where 3 and 5 will fall. So this is how addition is visualized. Right? Subtraction is not a great deal, because when you subtract, let's say if you have two complex number, again 1 plus maybe 2i, which is represented by 1 comma 2, and we have 2 plus 3i. So 2 plus 3. So fundamentally you can feel like 2 plus 3i is 2 comma 3, right? And this guy is nothing but 1 comma 2. An apple and orange axis, or real or imaginary axis, whatever you call it. So now from here we can clearly see what if I take 1 plus 2y minus 2 plus 3i. So algebraically it's 1 minus 1. Apple will give minus 1, and oranges we have minus 1. So basically it feels a little bit non-intuitive to tell minus 1 apple and minus 1 orange, but imagine in a virtual world you have negative orange and apples. Okay, they do exist in some meta world. So now this again you can feel like minus 2 minus 3i is nothing but just this reflection, because if this guy is 2 comma 3, this represents minus 2 comma minus 3. Right? So you have minus 2 comma minus 3 over here. So now we need to add this vector with this. Okay, so we have one point over here, other point here, and what is their summation? And you know, exact the same principles. I'll make a line parallel to OA, let's call it B, and then passing through A, which is parallel to, you know, like OB. So if we'll do so, we'll land here, and that becomes a parallelogram. Again, if we'll do XY using midpoint, this point is nothing but minus 2 plus 1 and minus 3 plus 2. So that's exactly minus 1 comma minus 1. And which again makes sense, because now you're getting, you know, like kind of this diagonal where one of the is mundi is here on minus 1 comma minus 1, is tail और इसका tail जो है वो already 0 comma 0 पे है. ठीक है, so you represent a complex number z which is x plus iy, or is equivalent to x comma y. You can treat this, we represent this as a vector which starts or originates from 0 0 and ends at x comma y. Just a way to visualize it. Okay, you can visualize it even as x I cap plus y j cap in vector form, or maybe x y in matrix form. Even in matrix form it's equivalent to x y 0, or even it can be visualized in R and theta in polar format, which we'll see. So it all depends on how you look at the things. Okay, so addition and subtraction is nice. So the takeaway is, if you have got z1 and z2, z1 plus z2 is this vertex, one of the vertex, and z1 minus z2. So we can take z minus z2 exactly there. Now if we'll draw a parallelogram out of this, so this guy will be z1 minus z2. Okay, so physically you can see these two coordinates lying over. z1 plus z2 will have some x part, some y part. Similarly, z1 minus z2 will have, you know, run and then right. Okay, run and right. So that's clear how we pictorially see this. Let's take a question, and in the next lecture we'll see the multiplication of complex number. So if we take 1 plus I square till I to the power 10, what we'll get? Clearly you can see I is I square is going to be minus 1, I cube is I times I square. We can use all that basic rules of algebra. So I into minus 1, so minus 1, and I4 is I square times square, which is minus 1 whole square is 1, and things repeat, right? So it's 1 plus I minus 1 minus I plus 1. So from I to I4, we'll have one cycle. Again, I5 is same as I minus I plus 1, and so on and so forth it will go. So how many boxes of length 4 will have? So it's 10. So 4 element I have already exhausted. 4 is other 8, and we are left with the remaining 10, which is I9 plus I10. Right? Now these 4s you can easily see they are 0. So we will have 2 more box which will die. So we are left with 1 plus I9 plus I10. Now I9 is same as, okay, it's, you can think of I squared to the power 4 into I. This is I squared to the power 5, right? I squared is minus 1 to the power 4 is 1. So it becomes 1 plus I, and that is minus 1. So finally we are getting the answer. So what does it mean? First, if we decode this, it means you put k equals 1 here. So I, k 2 I square till I to the power n, right? And then product. Then you have to write product of where n is going from 1 to 5. Now, in this expression, one way is you can use GP and try to directly find this number, which is I to the power n plus 1 minus 1 by I minus 1. And now I start plugging n equals 1, 2, 3, 4, 5, and pi means multiply them. Get that. Here you can likely do it directly, because if I'll, in this expression, if I'll keep n equals 1, I'll just get I to the power 1, which is the first term, into put n equals 2. So I plus I square, 3. 4, and then we can take I equals 5. And now we can clearly say I into I plus I square is going to give you I minus 1. Third quantity is I minus 1, that's minus I. Third quantity which you can calculate is I minus 1, I cube is minus I, and that's plus 1. Yeah, so that will die, that will give you 0. So again I minus 1 minus I plus 1. So I5 is I4 into I, so that will be I. If I calculate it, I square is minus 1, and here this is gone. So it's minus 1 into I minus 1, which is basically I minus 1. So this is the answer that we're getting. Let's take one last example. If we have 1 plus ki sigma k equals 1 to 10. So all these are basic NCERT examples. Put k equals 1, 1 plus I plus 1 plus 2I till 1 plus 10I. And that will give the answer where 10 times 1, 10 plus 55I, right? Because I common 1 plus 2 till 10 will give you I times 10 into 10 plus 1 by 2, which is giving 55I. Let's solve one of the challenging question. So suppose we have 8 complex number which satisfied z1 plus z3 plus z5 plus z7 equals 9, z2 plus z4 plus z6 plus z8 equals 10, z1 plus z2 plus z4 plus z8 equals 16. So we have 8 complex number which satisfy this. We need to find z3 plus z5 plus z3 plus z7. And again, that's not too difficult. You can give a pause and think. So you know, like in the first two, if you see, we have z1, z2, z3, z4, z5, z6, and z7, z8, right? And we have 1, 2, 4, 8. So if I'll add the first two equations, we'll have z1, z2, z3, z4, z5, z6, z7, z8, and that's giving 19. Now the last equation is z1, 2, 4, 8, right? So what is missing is, out of these two equations you can clearly see z1 is already available, z2 is available, z4 is available, Z80 Z11. So what's missing is 3, 5, 6, 7. That's exactly the one. So I'll subtract both equations. This is 16. So if we'll subtract, we'll get exactly Z3 Z5 plus Z8 plus Z7, which is 90 minus 16, which is 3. Okay, so this was a basic question in complex number addition. The point was just to expose you with the meaning of addition and how in a geometrical way it is being used. Okay, so now you can solve the first exercise of NCERT, which is 1.1 based on addition.